Now let's study about the polymers and their monomers. Now the first polymer is polythene. Now the monomer for polythene polymer is ethene molecule. Now it is important to note that polythene is basically of two types, high density polythene and low density polythene. High density polythene is prepared at a temperature of 333 to 343 Kelvin and with a pressure of 6 to 7 atmosphere in the presence of Ziegler-Natta catalyst, that is titanium tetrachloride and triethyl aluminium. The reaction occurs by free radical polymerization. It is generally used in buckets, tub, pipes, bottles and toys. What is important to note here is it is translucent. Next is the low density polythene. Temperature is around 350 to 570 Kelvin with a pressure of 1000 to 2000. There must be presence of trace of oxygen or peroxide. The reaction is free radical mechanism. It has branch structure and it is transparent. It is generally used to prepare plastic bags and films. The next polymer is polyacrylonitrile. It's also known as PAN or Orlon. So what is its monomer? That is acrylonitrile. So we have replaced one hydrogen with cyanide. Now the next polymer is Pvc Polyvinyl Chloride and its monomer is vinyl chloride. So we have replaced one hydrogen from ethene molecule with chlorine. The next polymer is polystyrene. Its monomer is styrene. So we have replaced one hydrogen from ethene with a benzene ring. So our next polymer is Pmma, that is polymethyl methacrylate. So its monomer is methyl methacrylate. In the ethene molecule, one hydrogen is replaced by CH3 group and another by COOCH3. So the molecule is methyl methacrylate. Our next polymer is Teflon, that is polytetrafluoroethene. Its monomer is tetrafluoroethene and it is used in non-sticky utensils. Moving on to our next polymer, we have terylene or Dacron. Its monomer is ethylene glycol and terephthalic acid. What's important to note here is that it is basically a polyester. So which of the following is an example of a polyester? Our answer will be terylene or Dacron. So we have studied in the organic chemistry that whenever a carboxylic acid reacts with an alcohol, it forms ester plus water. So Dacron is a polyester. So it is a combination of diols or diacids. It is an example of condensation polymer. The reaction occurs at a temperature of 420 to 460 Kelvin in the presence of catalyst, that is zinc acetate and antimony trioxide. So this is also an important point to note, the catalyst used during its preparation. Now it is also example of a transesterification process. The use of this polymer is in mylar film, that is used for magnetic recording tapes. Our next polymer is glyptal. Now glyptal is a polymer which contains ethylene glycol and phthalic acid as monomers. So it is generally used in paints and lacquers. This is very important point. Glyptal is used in paints and lacquers. Our next polymer is natural rubber. Its monomer is known as isoprene, which is basically 2-methyl-1,3-butadiene. What's important to note here is that natural rubber consists of cis, while if this monomer is attached or polymerized in trans form, it is known as gutta percha. Now, natural rubber has weak van der Waals forces of attraction. It is cis coil structure and it is non-crystalline. It is elastic in nature. So these all are the properties of natural rubber. That is the cis form. If we talk about the trans form, that is the gutta percha, it is having zigzag chains, its stretching is less, it is non-elastic, and it is crystalline in nature. So natural rubber is non-crystalline while gutta percha is crystalline in nature. Next, let's understand the term volcanized rubber. It is basically a process of heating natural rubber in the presence of sulfur. Now, natural rubber has some problems. It is basically soft and sticky. The second thing is it has large water absorption capacity. Next point is that it's having low tensile strength and it can be easily attacked by oxidizing agents. So generally during the reaction we use zinc oxide to accelerate the reaction. So there are presence of sulfur bridges or cross links in vulcanized rubber. Now tire rubber basically contains 5% of sulfur, ebonite contains 20 to 25% of sulfur, battery case rubber contains 30% of sulfur content in it. Now this point is again very important regarding vulcanization of rubber, that sulfur cross links are formed at the reactive allelic sites. Please remember that sulfur linkages are present at the allelic sites. Now let's talk about some synthetic rubbers. Next polymer is our neoprene. Now the monomer for neoprene is chloroprene, which is basically named as 2-chloro-1,3-butadiene. Generally we use oxygen or peroxide in this reaction. So polymerization is basically found to be slower in the absence of oxygen. Now if vinyl acetylene is reacted with HCl, it forms chloroprene. So there may be a question that in a molecule A you are adding ammonium chloride and copper chloride to form a molecule B, then you are adding HCl to form C, then it is polymerizing in the presence of oxygen to form D. What is A, B, C, D? So our A will be acetylene molecule, our B will be vinyl acetylene, C will be the chloroprene, and D will be the neoprene or our synthetic rubber. So this type of question again is very important for the entrance exams. You can be asked to name what is A, what is B, what is C, and so on. Now moving on to our next polymer, that is codal. So its monomer is dimethyl terephthalate and 1,4-dihydroxy methyl cyclohexane. Now please remember that this is also example of polyester. So codal is again a polyester. Now let's move to our next polymer, that is Lexine. Its monomer is phosgene and bisphenol. So again it is a copolymer. It has two different types of monomers, phosgene and bisphenol. It is an example of polycarbonate, and it is a polyester with two ester groups bonded to the same carbon. So this point is important one, and it is basically used for making bulletproof windows. This is the importance of Lexine. Now our next polymer is Pmma S. This is very important for exam point of view. Pmma S. Now the monomers are styrene. S in the Pmma S is for styrene. Bu, that is for 1,3-butadiene. It is also named as SBr, that is styrene butadiene rubber. So what are the monomers of SBr? What are the monomers of Pmma S? Now Na is for sodium. So this is very important for exam point of view. Our next polymer is Pmma N. Now Pmma N has monomers of 1,3-butadiene and acrylonitrile. So this reaction occurs in the presence of a peroxide as catalyst. So what are the monomers of Pmma N? That is 1,3-butadiene and acrylonitrile. So these are basically the polymers. We will discuss about the other polymers in the next video.